In the last video for this section, we're going to ask ourselves, what if we want to go backwards from the typical type of problem that we've been seeing before? So in all of the other problems that we've looked at, we've either started with some real-world data value or perhaps a z-score, and then we've used our normal table to help us find a probability or percentage, or if you want to think about it as an area under your normal curve, that's what we've done up until this point. In this section, we're going to say, well, what if I want to go backwards? What if I'm starting with a probability or percentage or an area on my normal curve, and I want to go backwards in particular to find that real-world data value corresponding to that? So let's take a look at a few examples. This says body temperatures of healthy humans are distributed nearly normally with a mean of 98.2, so my mean is 98.2 degrees Fahrenheit, and a standard deviation of 0.73 degrees Fahrenheit. So sigma is 0.73. So part A asks, what is the cutoff for the lowest 3% of human body temperature? So we're looking for that lowest 3%. And you can see in this case, we are given a percentage. So I want to find a real-world data value, which in this case is going to be a body temperature related to that lowest 3%. Just like we've done in all of our other problems, I think it's really helpful to draw out a picture for what it is that we're thinking about. So that lowest 3%, on my normal distribution, it looks something like this. My mean is 98.2. It lives somewhere here in the middle. So first thing I need to decide is where is this data value going to live? I know that the mean cuts my normal distribution in half because it's symmetric, meaning 0.5 is the area to the left of my mean, and 0.5 is the area to the right of that mean. I want the area, in this case, to the left, because we're talking about the lowest, to be 3%, or 0.03. So because this area, 0.03, is less than 5%, I know it's going to live somewhere over here. So I know that there is some number. I don't know what it is. We're going to try and find it so that the area to the left of that number is 0.03. And I can tell again that this point lives to the left of the mean instead of somewhere over here on the right because 0.03 is less than 0.5. Okay, let's go ahead and continue on. Let's erase these just so we're not looking at these. What I'm going to be looking for is what's the real-world data value corresponding to this. In this case, I have my area on my normal curve. What's this number right here? That's what I want to know. Well, the first thing that I'm going to have to do is I'm going to have to find the z-score corresponding to this number. I'm going to have to start by finding the z-score, and then once I have that, I can work my way backwards to find the observation. Which means, yes, I'm going to have to use my z-tables. So I want to keep this number in mind, this 0.03. So if I hop over to my z-tables, the thing that makes these problems, I think, a little bit trickier is we're so used to looking at a z-score over here and up here, and then we're finding this area in the middle. We're not doing that this time. We're actually going to start with all of these numbers in the middle, and we're going to work backwards to find our z-score going across. So we are going to have to wade through this mess of numbers right here. Now, the picture that I drew was extremely helpful because it said, hey, I want the area to the left to be 0.03 or 3%. So what I need to do is I need to look through this big mess of numbers here in the middle, and I want to find the number as close as I can to 0.03. You may end up kind of partway between those two. We can usually find which one's the closest. So I'm going to look for 0.03, and I see here's like 0.0256. That's not quite big enough. Here's 0.0322. That's too big, so it's going to be somewhere between those two. And if I look to the left of this number right here, 0.0314, 0307, 0301, 0294. It's going to be somewhere between these two numbers. So I know I'm looking at those two numbers in particular. And then I'm just going to pick whichever one is closer. And if you need to do a little bit of subtraction, you could do that. You could take 0.0301 minus 0.03 and 0.0294 minus 0.03 and determine which one is closer. But it turns out it's going to be 0.0301. This is the z-score that I want, or rather, this is the area that I want. It's as close as I can get to 0.03. So what I need to now do is find the z-score corresponding to this number. So I'm going backwards. I'm saying I'm looking at this row right here. This is the row I live in. So it's going to be z equals negative 1.8. I'm looking at this right here. And then for the second decimal, it is, in fact, also 8. So, it's also 8. So, negative 1.88. So, the z-score corresponding to this number is negative 1.88. Let's hop back. Yes, so z is negative 1.88. So, I need that z-score. At this point, we have everything we need. We should be able to find our real-world data value. There's a couple different ways we can do that. You can just use the regular old z-score formula and do just a teeny tiny bit of algebra. So let's start with that way first. Your z-score formula says z equals x minus the mean divided by the standard deviation. And remember that x value represents our real-world data value. And at this point, we have the z-score, we have the mean, we have the standard deviation. We can plug those three numbers in and just solve for x. So let's do that first. We'll show that method first, and then I'll show a little shortcut. So z is negative 1.88 is equal to x. I don't know what that number is. That's what I'm trying to find. Minus the mean, 98.2, divided by my standard deviation, 0.73. And then at this point, we just have a little bit of algebra to do here. So if I want to get rid of this 0.73 in denominator, I'm going to go ahead and multiply both sides by 0.73 times 0.73. So negative 1.88 times 0.73, that will give me negative 1.3724 is equal to x minus 98.2. And then to finish up my algebra again, I'm solving for x, which means I need to get rid of this minus 98.2. Well, the opposite of subtraction would be, of course, addition. So plus 98.2 plus 98.2. So I end up with x on the right-hand side, which is what I want. So plus 98.2. I ended up with 96.8276. Perhaps we'll round this to 3 decimal places and we'll say 96.83. So this z-score corresponds to 96.83 degrees Fahrenheit, and that would be my answer. That's the body temperature that separates the lowest 3% from the top 97%. That's what this problem is looking for. Now, if you didn't like that way of solving for the observation, what we can do is we can solve for x in general terms, and then we'll have a formula that we can always use. So if you said, this algebra is a little bit too much, I don't really want to do it every time, say no more. So what I can do is if I go back to my formula, what I'm going to do is I'm going to solve for this x in terms of all my other variables. So unfortunately, there's no getting around it. I'm going to have to do a little bit of algebra, but this way, I do the algebra one time, I never have to do it again. So I'm going to start, if I say, okay, I want to solve for x, I'm going to start by multiplying both sides by my standard deviation. So times my standard deviation. So that will cancel these two, which is what I want. Z times my standard deviation is equal to x minus the mean. Again, I'm trying to solve for x, so let's go ahead and add the mean to both sides. So plus the mean. So I end up with z times the standard deviation plus the mean is equal to x. And this gives me a way that I can solve for that observation, just a quick little formula that I can plug in my z-score, my standard deviation, and my mean all at once. So let's do that real quick here. If I wanted to double check, make sure I should get the exact same answer, regardless of which method I choose. My z-score was negative 1.88 times my standard deviation was 0.73 plus my mean was 98.2. Let me grab my calculator, make sure everything looks good. Times 0.73 plus 98.2. I ended up with 96.8276, which is exactly what we had last time. So I don't really care which of these methods you use. I will say that this formula will be a part of the formula packet that you're given on exams and quizzes and whatnot, so you don't necessarily have to have that memorized. But if you like doing the algebra, then of course you're free to use that method as well. Let's take a look at a couple more just to make sure we feel okay with this process. Part B says find the body temperature corresponding to the 85th percentile. So this time around I'm talking about a percentile, which is a little bit different. This means that 85% of my data values are less than this value, less than or equal to that value. So again, let's draw out a picture so that we can see what it is that we're looking at. My mean is 98.2. And again, if you want to think about where this point lives, 0.5 lives on the right, 0.5 lives on the left. I want the area to the left to be 85%, or 0.85. Well, that's bigger than 0.5, which means this time around it's going to live somewhere over here. It's going to live somewhere over here on the right. So let's go ahead and erase just so that we've got this. So I know that the area to the left of some number, I don't know what that number is. That's what we're going to try and find. The area to the left of that number is 0.85. This number represents the 85th percentile. So again, we're looking for a real-world data value. And I have to start by finding the z-score corresponding to that number. So my z-score, we want the area to the left to be 0.85. I'm going to have to jump back to my z-tables. So the area to the left to be 0.85. Now if I look at this table right here, these are all my negative z-scores. These are all going to be less than 0.5. I need a positive z-score. So it's going to be somewhere over here. Let's erase, just so that we can start fresh. I'm going to look for the number as close as I can, again, wading through all these middle numbers right here, as close as I possibly can to 0.85. So like here's 0.89, that's too big. 0.87, 0.84, that one's too small. So 0.8485, and here's 0.8508. So it's going to be somewhere between those two. And again, if you need to do a little bit of subtraction to determine which one's going to be closer, you can. But it's going to turn out that 0.8508, that number is a little bit closer to 0.85. So that's the number that I want. So if I wanted to find the z-score corresponding to that number, well, that lives in this row. So our z-score starts off as 1.0, z equals 1.0, and then the second decimal right here lives in this column, would be 0.4. So 1.04, and actually I already wrote it out because I knew the answer. So z equals positive 1.04 would be the z-score corresponding here. So if I hop back to my example, my z-score we said was positive 1.04. And at this point, I have everything I need. I can go ahead and plug it into the formula that I found last time. So we said x is equal to z times the standard deviation plus my mean. So my z-score was 1.04 times my standard deviation. We said that was 0.73 plus my mean of 98.2. So let's see, 1.04 times 0.73 plus 98.2. I ended up with 98.9592. Let's go ahead and round that to 2 decimal places. So that would be 98.96 degrees Fahrenheit. So anytime we are asked to find a percentile, what that question is really asking for is a real-world data value, whatever it is that you're talking about in this problem. So in this case, it was a body temperature that we're looking at. Let's look at one last example here. Part C says, what is the cutoff for the highest 10% of human body temperatures? So this one's a little bit different because I'm not looking at area to the left, I'm looking at area to the right. So we're going to have to be a little bit creative, but shouldn't be too bad. You can probably guess the tools that we're going to use. So my mean, 98.2, once again, lives right in the middle. The highest 10%, again, so this time around we're talking about area to the right. This 10% is less than 0.5, so that means that this number is probably going to live somewhere right here because I want this area to the right to be 10%, or 0.1. I'm trying to find out what this number is. So we have to remember that our Z table does not tell us area to the left. It only, it does not tell us area to the right, It only tells us area to the left. But I can find that very quickly by taking 1 minus the area to the right to get 0.9. So that means when I go to look up this Z-score, the area that I'm going to be looking for in that middle section is actually 0.9 and not 0.1. That's going to be really, really important because otherwise we'll end up with the wrong sign. So we want a positive 0.9. So hopping back to my Z table one last time, I'm going to be looking for, we said, 0.9. So we want 0.9. So let me write that down. My area is 0.9. Okay. So I'm looking at these. I see 0.88, 0.90. It's going to be somewhere between these two. Okay. Let's move to the right. How about 0.888, 8907, 8925, and I'm going to just jump ahead right here. I'm looking at these two. Oops. Nope, not those two. These two right here. I'm looking at those two. There's where the change happens between 0.89 and 0.90. So I know it's going to be one of those two particular Z-scores. I'm going to pick whichever one is closer. Again, if you need to do subtraction, you can do that, but it turns out that 0.8997 is going to be a little bit closer. So to find the Z-score corresponding to this one last time, here is positive 1.2. So my Z-score, let's start off, my Z-score is 1.2, and then the second decimal place, it lives in this column, so it should be 1.28. So my Z-score is 1.28. So hopping back to my example one last time, the Z-score corresponding to this is 1.28. And then again, I can use the formula that we derived up here for x to find our observation. So x is equal to z, 1.28, times my standard deviation, 0.73, plus my mean of 98.2. So grabbing my calculator one last time, 1.28 times 0.73 plus 98.2, I ended up with 99.1344, or 99.13 if we want to go ahead and round to 2 decimal places. So there's our real world data value. As you're working through the homework problems for this chapter, just be aware and be thinking about, okay, are we starting with that real world data value, or are we starting with that probability, that percentage, that area? Because that informs what part of the Z table that you're going to look at and